Hello, welcome. Today we're going to discuss the chain rule of differentiation. Now let me show you. What you can see towards the left hand side is the way I learned the chain rule, and this is the way I want you all to learn the chain rule. So understand a simple concept. If you're differentiating the mother, you need to leave the baby inside. So you're only differentiating the outer thing, leaving the inside thing intact. Now after you have differentiated that, you're going to differentiate the baby. You're going to differentiate what is inside. So this is how I learned, and this is how I want you all to learn. Let's go ahead. Now you must be knowing the differentiation of sin x and cos x, and if you don't know, I would urge you to go to the basics to learn the formulas and all, and then come back here and continue the video, because this is very important. So we know d by dx of sin x is cos x, and d by dx of cos x is minus sin x. Simple. Cool. Let's go ahead. This is a formula which I mentioned in the last slide, so let's go ahead. Now coming to the main question, when we're differentiating sin square x, what would be the answer? We know when we're differentiating sin x, it's cos x. But when we're differentiating sin square x, what would be the answer? Will it be cos square x? No. So that's why we're gonna understand the concept of chain. How chain rule happens, what all process we go through. So whenever there is more than one function with a function, it cannot be differentiated so easily. So let's go ahead. So if we are differentiating x squared with respect to x, the answer would be 2x. If we are differentiating a square with respect to a, answer would be 2a. If we are differentiating the chocolate square with respect to chocolate, what would be the answer? It would be 2 chocolate. And if we are differentiating sin x square with respect to sin x, what would be the answer? Sin x. Simple. So this is a very basics. If you are on the same page, you can understand very easily the chain rule. So this is the answer. Chocolate square, if you're differentiating, it will be 2 chocolate, and sin square x with differentiating with sin x would be 2 sin x. Cool. Now the main question by which we started this is we have to differentiate sin x whole square, or we can say sin square x. Both are the same thing. And for that, we have to differentiate it with respect to x. If we were to differentiate sin square x with respect to sin x, you can see in the very last thing, we would have easily got the answer, it's 2 sin x. But here we're going to differentiate something which is sin x square with respect to dx. So it would be like we need to apply the chain rule. So let's see ahead how. So the chain rule works this way. You have x you will put sin, it will become sin x. And when you have sin, you square it, it becomes sin square x. Simple. And now we have to treat them individually. We have to differentiate sin x with respect to x, that's the case 1. And we have to differentiate sin square x with respect to sin x. So now we very well easily we can say that d by dx of sin x with respect to x would be cos x, and d by dx of sin square x with respect to sin x would be 2 sin x. Now let's understand this step by step in detail. When we have x, we make it sin, it becomes sin x. Sin x on squaring becomes sin square x. Sin square x on differentiating with sin x becomes 2 sin x. And sin x differentiating with dx become cos x. Now if we cut the d sin x part, we'll be left with d sin square x upon dx. And if you go back, you see this was our question, d sin square x upon dx. Now we achieved a question. So what we have to do is we multiply 2 sin x into cos x. That's the answer. Simple. So d sin square x upon dx is 2 sin x cos x. Simple. Now we understood what is chain rule, right? Let's do another question to understand it better. So d by dx of, we have to find a differentiation of y is equal to sin x square. Now what is the difference here is we are putting sin with x square. X is already in square. So whole of the sin x is not in square, just only x square which have sin along with it, right? So what we're going to do is, last time we did first sin and then squaring. This time we're going to do x squaring first and then put the sin. X on square becomes x square, and x square on putting sin becomes sin x square. Let's see the treatment. So we're going to do differentiate d x square, differentiating with respect to x. We'll get 2x, and then we're going to differentiate sin x square with respect to x square. It would be cos x square. Simple. And now we cut off the dx square, we'll get 2x cos x square. So if you see the change in answer, last time we received the answer is 2 sin x cos x. This time the answer is 2x cos x square. So that's the chain rule, and I hope you understood the chain rule. Now let me quickly discuss with you some of the questions, some of the very practical questions. You can try practicing them. So the first question is 6x squared plus 7x whole power 4. So what we're gonna do? We're gonna treat it as a mother, and we're gonna differentiate only the mother, not the internal part, right? So we have 4 in the power. We'll treat it as normally x ki power 4. And what we do that? We'll put 4 ahead, 4x cube, right? So half answer would be 4 6x squared plus 7x whole power cube. Now we're going to differentiate the inside part, that is 6x squared plus 7x. That would be 6 into 2, 12, 12x plus 7. So the whole of the answer would be 4 times 12x plus 7 multiplication of 6x squared plus 7x whole cube. Now going to the second question, we have 4t square minus 3t plus 2 whole of the negative power negative 2. So we're going to take negative 2 in front, negative 2, 4t cube minus 3t plus 2 whole of the power minus 3. Now we're going to differentiate the inside part, that is the child, that is 8t minus 3. So we got the answer. Answer is minus 2, 4t square minus 3t plus 2 whole to the power minus 3 multiplication 18 minus 3. So I think you got the solution, right? Let's go to the third question. Third question is y is equal to 1 minus 8x ki whole power 1 by cube. If we have 1 by cube, we take 1 by cube in ahead, so it will be 1 by cube, then 1 minus 8z power minus 2 by 3. When we are subtracting 1 by 3 minus 1, it will be minus 2 by 3. And then we're going to differentiate the inside part. 1 would be 0 and minus 8z would be minus 8. So the answer would be minus 8 by 3, 1 by 8z minus 2 by 3. Let's go to the fourth question. The fourth question is cosec 7w. Now we know the formula cosec. That's why I asked you, if you don't know the formula, you have to go back and recall. For the formula of cosec, you must know that it is negative of cosec cot x. So what we're going to do is we're going to first do the outer thing, that is negative of cosec 7w and cot 7w. And when we do 7w, that is internal thing, we'll get 7 also in front. So the answer would be 7 minus 7 cosec 7w cot 7w. Let's go to the second last problem. So the second last problem is 2 sine 3x plus tan x. Okay. So now what we have to do is we have to consider the sine. So what is the formula of sine? Sine formula is cos, right? So the answer would be cos 3x plus tan x. That's the outer thing, and 2 would be intact in front because we can't differentiate 2 since it's multiplication. And then we're gonna do the inside thing. So 3x would be 3 plus tan x would be sec square x. So the answer would be 2 times 3 plus sec square x. Then multiplication of cos 3x plus tan x. Now coming to the last question. Now the last question is tan 4x plus tan u. Now you must be knowing the formula of tan is sec square x. So we're going to do sec square 4 plus tan u. Now we're going to differentiate 4 plus tan u. That would be 0 plus 10. So the answer would be 10 sec square 4 plus 10 w. With this, we come to the end of this video, and I hope you practice these questions. And if in case you have any doubt, you may reach out to me on commenting on my video. Thank you very much for watching till the end. Thank you, and let's study hard.